everyone, Miss Bonnie here. We are ready for our monthly STEM Junior program, and I will tell you 3 out of the 4 experiments all have to do with water. So the one thing I want to remind everyone, which I do in the beginning of every STEM Junior program, is these are experiments. And remember, with experiments, they don't always work out the way you would hope they would work out. But we're going to try it. We'll see what happens. So the very first program or experiment that I wanted to try was called Dancing Corn. And the way it works is we want to be able to see the corn actually dancing in the jar. Now I'm going to first attempt to do it in this smaller jar, and we'll see if this is going to work or not. So you need about a cup of corn. Now this is the old-fashioned corn where you actually have to pop it in a pan on your stove or maybe outside in a fire pit. So you need about a cup of that. And you have a jar, and I'm hoping this jar is going to be deep enough. And I'm going to put the corn in the jar, just like so, okay? Now the other things that you're going to need is baking soda, and you're going to need white vinegar. I put everything in an aluminum pan, though the suggestion is you might, your parents might want you to put it in the sink because it might fizz up. But I think the aluminum pan will do just fine. So I poured the corn into the jar. Then I need to put in 2/3 of a cup of white vinegar. And I know that this is not enough, but we'll start with this. Here's my white vinegar. Let's put in some more. So we have 2/3 of a cup. Okay, so now I'm going to take the 2/3 of a cup white vinegar and pour it in with it. And I have a feeling that's not going to be enough. So let's put more in. Because I think what it's hoping is that you're going to see them come to the top, hopefully. All right, so then I'm going to take some baking soda, and I'm going to pour in slowly 1/4 of a cup of the baking soda. Now, Miss Meg, can you actually see the whole cup so that it's popping if we can get that far? All right, so I'm going to take and dry this out a bit. Okay, and I think I might just try pouring a little bit in at a time. And let's take a look and see what happens to the vinegar and the baking soda. All right, is that cool or what? Look at that fizz. Now, I'm seeing maybe just a couple of the corn trying to pop up. We can see that. See, as it's coming up, I'm going to put a little bit more in. Let's see what happens. Okay, it continues to. Woo, look at that. Now, when the bubbles die down, we should be able to see the corn actually going up and down almost like it's an elevator. See how they came up? Miss Meg, can you see the middle where it's actually cut in half? Cool. So there's actually a space between the lower portion of the corn and the upper portion. Now look and see what happened. Did you see it drop? That dropped because the bubbles were all gone. Now you're going to see, like they claim, the elevator of the popcorn slowly going up and down. What you can do also is stir it when it slows down. Let's see what happens. It will start again. It's supposed to start again. Let's see. I could really fake it out, and I could put some more of this in, I'll bet. And watch it fizz again. And you can do this on and off for a number of times. the heavy corn, and you wouldn't think, why is the corn coming up in the jar? Well, the corn is coming up because it's attached to those air bubbles. See the air bubbles? And it's still coming up. And once the air bubbles are gone, that's when the corn starts to drop again, because the air bubbles are they can even take those heavy corn kernels and raise them in the jar. And I love the way it actually separates the corn in half. And you could see the lower half is also trying to bubble up to the upper half of the corn. So I think that's a cool one. That's our dancing corn, okay? So let's go on to another one. Right. So another water experiment we have here, and what we're actually going to do is make a tornado in a glass. Here's my glass. And this kind of will show you how the vortex is formed and how, with a real tornado, how it begins to spin around and around. And what you need for this particular one is actually, you need water, of course. Here's my water. I also have liquid soap that I'm going to use here. In addition, I actually have some kind of big glitter to see if that's going to move the glitter at all. So these are kind of big chunks. As you can see, big chunks of glitter that we're going to use. And I'm going to use a stirrer. And since I used the stirrer for the previous experiment, I'm going to wipe it off because I don't want any of, say, the baking soda or anything else to change the way this experiment is going to work. So I'm going to fill a glass 3/4 of the way full with water. What do you think? 3/4? I think that's probably 3/4. If not, we'll add some more afterwards. I'm going to put a few drops of dishwashing liquid in the water. Just a few drops. Add more if we need to. This is so that you'll be able to see it a little bit better as we do this, okay? Now, I'm going to hold the glass with one hand, and with the other, I'm going to very, very quickly, you're going to watch the water, okay, in a circular motion until the vortex, okay, or the column in the middle begins to spin around. All right, can you see how it's spinning in the middle? See, just in the middle? It's becoming a V shape. If you can really, I can see it from here. Actually, Miss Meg, can you see it right underneath the surface? See it? Mm-hmm. Wow, that is cool. That is really cool. That works just like a tornado. And to be honest with you, when I was reading about this, what I thought was interesting is, I don't know if any of you have seen a water spout on the ocean. I'm thinking to myself, I'll bet the water spout works the same way. The tornadoes are really just the air circulating into the vortex. But think about those water spouts where off in the distance you could see it looks like a tornado coming across the water. Now, I'm going to add some chunks of glitter to see if the water current will move now. All right, so I'm going to hold it up, and here we go. See the tornado in the middle? To be honest with you, I think that tornado is even easier to see with the glitter in the middle of it. So to me, when I think of a tornado, remember how we hear such stories where it literally lifts up houses or a roof off of a house or a car. That's exactly what you're seeing here in a smaller version. because that glitter, because of that vortex in the middle, is being lifted up and it spins around. So that's, I think that's an interesting type. When you stir the vortex created in the center, makes it look like a tornado. The water swirling on the outside actually has to move faster than water on the inside to keep this up. So think about that. Think about even the hurricanes, same kind of situation where the wind is very, very high, even way out from the calm eye of the storm. And that's because of that vortex and that turning around and around. So that's the tornado in a glass. Now, before we do our last water experiment, I wanted to do another experiment for you. And I think we talked about that I was hoping that every time I would do at least some form of a body experiment as well. So this is a very simple body experiment. And I think, Miss Meg, I'm going to actually have to go near this wall. You need to have a wall that you can lean on, okay? And this is a very simple human body science. And I'm going to try it once. If that doesn't work too well, I might try the other foot. It's all about, first of all, standing on one foot. Now, you don't have to stand on the one foot for 5 minutes. You just need to stand on the one foot for a brief period of time. So I'm going to do that. I'm not leaning against the wall at this point. So I'm going to stand on one foot. Okay? I'm going to do that again. Now, I'm going to move to the wall. Okay? So that one foot is against the wall. Now what you want to try to do is take that foot and raise it so you're on one foot again. I can't do it. You cannot raise the other foot because you're leaning against the wall. Now before I explain that to you, maybe Miss Meg would like to come over and she could try it as well.
Ooh,
So is that all set? So
yeah, I think if I stand in the same spot.
Yeah, let me take a look. Okay, we're gonna get Miss Meg involved in this experiment with us.
Me?
We can see you great.
All
So
right.
get away from the wall.
I'm really good at standing on one foot.
Okay.
So I just lean against the
Now
wall?
look, lean against the wall.
No, not all the way. No.
You can't. Right.
I
Good.
wonder if I go further. Yeah, not really.
No? All right. Thank you, Miss Meg.
Mhm.
All right. So, can you lift the foot? No. I guarantee you, you cannot. Try again, and I will try this again. Okay. Here is me balancing. Here is me against the wall. Okay. I can't without falling over. Now, I'll get away from the wall, and I can lift it again. Why is that the case? Okay? When you went back, after you tried against the wall, and you lifted your leg and you were able to raise it, did you sense or feel your weight, your body weight, shifting slightly? Okay? When you lift one foot like this, your center of gravity, because right now when I have both feet down, my center of gravity is right here, okay? If I lift one foot, my weight is making it so I could be on just one foot, okay? I'm compensating for that new position by moving my weight to compensate for it, okay? Compensate means that it helps me to get to raise the one foot. But standing against the wall makes it impossible for you to shift your weight to compensate because you're pressed up against the wall. That's a very simple human body experiment. You ought to try it with your whole family. Have everybody try that one because that one is a lot of fun. Okay, so our last experiment, I'm going to move over here. And this experiment is called Magic Water. Now, this is the one I was most concerned about, and wasn't sure if this was going to work, and I'll explain to you why in a minute. I took a big bowl and filled it with water. And I may need to put even more water in there. This is why if you do this in the kitchen, on the counter, right next to the faucet, that way it won't spill. Okay, so I have my large bowl, and I filled it with water pretty far. And I'm going to add some food coloring to this. Shall we add some blue, maybe? Sure, why not? Let's see what happens. Of course, I'm going to get blue on me, but... All right. I added blue food coloring. What do you think will happen? And I'm going to use this glass first. We're going to try this out. What do you think was going to happen when I turn the glass upside down? Okay, first of all, I'm going to put it in just like you would if you were just dunking water in. But then I'm going to turn it upside down, and I'm going to try to lift it out of the water. Think about what might happen to that. So I add the food coloring, and I'm going to submerge the glass into the water. And I might have put way too much blue in there. Okay? Let it sink. And the reason why I wasn't sure about this glass, mainly because would it really fit the bottom? So now while it's down there, I'm actually going to take the glass and I'm going to turn the glass upside down. Don't take it out of the water. Turn it upside down. Okay, keeping it submerged. Slowly from the bottom of the bowl, begin lifting the glass up. Don't let the glass rise above the water surface. So looks like I'm gonna have to put some more of that. Okay, so I'm gonna start lifting that. Okay, lift it slowly. And I think I'm still gonna have to put more. And again, I wasn't sure about this one because of the shape of the glass. But I actually, as I'm trying to lift it, I can feel the water being sucked up into the glass to the point where it's pretty much in there, even though this particular glass has all that fancy stuff along the side. Once I break the surface with this glass, okay, the air pressure that was in there isn't going to be there anymore, all right? So try lifting the glass fully, and then all of a sudden, as you get to the surface, and again, really feel that glass. You can feel the water that's in that glass and the pressure that's keeping it in. Now I'm going to raise it above. Raise it slowly, because I have to tell you right now, this glass is so full of water, it is extremely heavy, and yet look at how far the glass is above the surface of the water. The air pressure is keeping the water suspended. It still is, and if you could see, you should be able to see the blue water in the glass. Now here I am, remember this is turned upside down, and right now water is all the way to the top of the glass still, even though we went above the surface. Okay? Now, forcing the water up in the glass, that's basically what it's doing. Then you're raising the glass, you begin to lose the pressure. Look at the blue. If you can see the surface, this glass is at the top of the surface, and it's still, it still had all that water in it until I lifted it far enough where the air pressure popped out of it and you could see the bubbles at that point. So that's called our magic water glass. It's kind of cool. I think if you were to do this, my suggestion would be probably fewer drops so that you could see it better, of the color, or use a lighter color possibly. So I hope you liked these 4 experiments. It was a lot of fun for me to do them, and to be honest with you, this is the first time all 4 of them worked, so I'm really glad about that. Enjoy watching this. Go right ahead and watch it over and over again if you want, so that you can really see how to do these experiments. I hope to see you again next month with some more STEM Junior programs. Thank you. Bye.